Thursday potluck movie night, and it's at the Phoenix Pride Center. We'll be showing Virunga. It's a documentary on mountain gorilla conservation. They're actually, the last of the mountain gorillas are basically stuck in one forest, and that forest is being chopped down. It's in the Democratic Republic of the Congo. So I think that's going to be really good. Our major campaign right now is called Arizona Progress for Science. Arizona Progress for Science is a coalition of animal and environmental organizations, community members, students, and other local activists who are taking a stand against animal testing in Arizona. The reason we're doing this is because ASU, U of A, Mayo Clinic, and Phoenix City Council have been planning for years to make Phoenix into a global hub for biomedical research. We deeply believe in the importance of medical research, but we also recognize the growing body of evidence demonstrating that investing in animal testing is losing credence as a scientifically sound practice. Our aim is to promote safer alternatives to animal testing, safer for animals, safer for the environment, and safer for human health. All three of these are seriously threatened by animal testing. To quote Dr. Elia Zerhouni, the former director of the National Institute of Health, "We have moved away from studying animal disease in humans, and researchers have over-relied on animal data. The problem is that hasn't worked, and it's time we stop dancing around the problem. We need to refocus and adapt new methodologies for use in humans to understand disease biology in humans." This can be demonstrated with the fact that only about 10% of drugs that pass animal trials also pass human trials. Conversely, consider how many drugs would have passed human trials but didn't pass their animal trials. Think about all the great medication we can have if we weren't relying on flawed science using animal testing. We believe that an investment in the future of medical science should invest in using human disease models, for example, lab-grown human tissues, rather than prolong the use of animal models, which has already been stretched to the limits of usefulness. If you're interested in making a difference with us, visit ArizonaProgressForScience.com and come back and talk with us afterwards. Again, we have more info on our social media at this website. And then finally, before I actually begin the actual talk, if you have any questions or don't understand something or what something means, just ask, interrupt me, whatever. We have plenty of time, and yeah.
We don't have time.
Oh shit! Yeah, we don't have time for inaction. So, water scarcity. That's what we're all here for today. So we're all here to learn about water justice, but how bad is water justice? We all know that despite the Earth being mostly covered in water, that water scarcity is a global issue. In 2005 and 2006, the Food and Agriculture Organization of the UN did a sweeping review of all the scientific literature about the impacts of animal agriculture on the environment. Their summary is that the world is moving towards increasing problems of freshwater shortage, scarcity, and depletion, with 64% of the world's population expected to live in water-stressed basins by 2025. The 390-page report also came to the conclusion that animal agriculture is not only the #1 cause of greenhouse gas emissions, environmental degradation, species extinction, and rainforest deforestation. They also found that animal agriculture is the #1 consumer of fresh water in the world. From 2006 to 2025, the Food and Agriculture Organization predicted that the number of people living in water scarcity would increase by 68%. So to be clear, a water-stressed basin is defined as having 450,000 gallons of fresh water available per person. Currently, the average American uses 770,000 gallons of water. That is a lot of water for a single person to be using. Can you think of 770,000 gallons that you use every year? It's 2,000 gallons today. However, 96% of this is from what's called hidden water or virtual water. It's water that's used to make the products that we purchase rather than water that we consume directly from a faucet. Hello. So that's to say, if you were to completely stop drinking water, stop showering, stop watering your lawn, stop all other water usage in your home, stop everything that you think of water usage, you would only cut back on 4% of your water usage. If you literally stopped everything, only 4%. But 70% of all fresh water goes to agriculture. That means for meat eaters, up to 70% of their total water usage occurs raising their food, meaning if we can make our eating habits more efficient, we can have the biggest impact on our overall water usage. So where does all this water usage come from? It comes from animal exploitation. With all of that taken, so with all the 70% of water is used by animal agriculture, it's no surprise that the FAO then followed their statement by saying, the livestock sector is a key player in increasing water use and is probably the largest sectoral source of water pollution. Over the course of the presentation, I want to explain in detail the many ways in which animal agriculture consumes a disproportionate amount of water. If you saw Cowspiracy earlier today and were wondering about the details behind all those numbers that they presented, you're probably going to like this and be a little shocked. So what is animal exploitation? For me, I always like to define the terms that I'm using so that we can all agree about them. In the title, we call out animal exploitation and water consumption. But if you asked everyone here, what is animal exploitation, you get 10 different answers. So to us, for here right now, animal exploitation means the use of animals to benefit from their lives against their will. Human exploitation of animals can be classified under 4 broad categories. Humans using other animals' bodies and secretions to make food, such as meat, dairy, and eggs. Using an animal's fur and skin to make fabrics and leathers. Exploiting an animal's life and their health for experiments. And finally, animals are also locked in cages against their will, forced to perform for human entertainment. Because of the scale of the animal-based food industry, where 56 billion terrestrial animals are killed every year by humans, and so many marine animals are killed that they don't even count them, they just measure it by the ton. I'm going to be just focusing on animal agriculture today. So what happens actually during the process of animal exploitation? If we want to make a burger or a glass of milk, I argue that there's 6 things that'll happen, and all of these things affect our water supply. Animal agriculture starts by clearing a lot of land, and we use that land to confine the animals in. But at the same time, animal agriculture starts by clearing a lot of land, and we use that land to confine those animals. But at the same time, we have to grow some feed for all those animals, so we got to clear even more land. Then after that, because the animals are so confined, they also get sick. So farmers add antibiotics to their feed, and once that feed is consumed, the animals turn it into a mountain of shit. And when it rains, all that shit runs off and it pollutes our rivers and our water tables. And once the animals have lived up to a quarter of their natural lifespan, they're killed and rendered into commodities, a process which uses many toxic chemicals. And after the animals' bodies have been rendered into commodities, the products are transported to be sold, often on the other side of the planet. And so let's dig deeper into all of these. So we'll start off with clearing land. Clearing land to raise animals takes a significant amount of space. Livestock accounts for 20% of terrestrial biomass on Earth, so it's no surprise that they also use 30% of the Earth's land surface. If you watched Cowspiracy earlier today, then you may remember how half the wild horses in the U.S. have been corralled to make space for cows to graze. Looking at this map, and if you look specifically in America, somewhere around right here, where all the grazing is happening, it's no surprise that if there's that much grazing happening, there's no space for horses. All that land is being used for cattle. And the reason this happens is because there's a federal program which allows ranchers to lease grazing land for cheap from unused federal land. The land is actually doled out for ridiculously low prices, way below their market value. For example, if you remember the Clive and Bundy case from last year where a rancher got upset because the federal government started rounding up his cattle that was grazing on federal land. Well, it turns out the federal government only took action only after he did not pay to use that land for 20 years. So people are basically offloading all this, cattle grazing and production that destroys our environment onto land that they're not even paying for. As you'll see, they end up ruining that land.
So, do you know what happened to that case?
I'm pretty sure he just lost and they took all the cattle and probably killed them.
Or did he pay the money and continue grazing?
I don't think he paid the money. I don't think he had the money. It's like thousands of dollars.
Right. Yeah. Hundreds of thousands.
Yeah. Yeah, but everyone, got upset about it. Oh, you're taking his cattle and this and that, and his, what he was doing wasn't even reasonable.
It wasn't legal.
Yeah. So this isn't just limited to America. Similar programs around the world make excess space available for animal farmers. This happens in China. It happens in the Brazilian rainforest. Specifically speaking of the Brazilian rainforest. So the Worldwide Fund for Nature Conservation, World Conservation and the World Conservation Union have all independently identified livestock as a current and major threat to biodiversity and cause of habitat loss. This video shows the progression of deforestation of the Amazon rainforest. Over the course of 24 years, you can see how the rainforest goes from mostly green to mostly developed land. Half of the world's rainforests have already been cut down. And according to Greenpeace, 80% of all that you see there is pastures for cattle to graze or to grow feed for cattle. So 80% of rainforest deforestation comes from animal agriculture.
So I guess when somebody would see that, they would think that, oh, that country is eating well because of that process, right? Mm-hmm. What would you say to that?
I don't know what eating is like in Brazil. I do know that actually, for example, most of these cattle, they're not getting eaten. They're actually being turned into leather. So we're destroying the rainforest for, an Italian purse. Yeah, so this picture is specifically in Brazil. This land used to be rainforest. Those cow are now dead. They've been turned into leather. And, well, why are we talking about land usage when this is a forum on water? Land usage is actually really important for considering the impacts of water quality because only 1% of fresh water usage comes from desalination plants. That means in some way, 99% of the fresh water we consume has to fall out of the sky, onto the land, and be used at some point before it reaches the ocean. Once fresh water mixes with the ocean, it costs roughly 10 times more to desalinate than if it's captured as fresh water. Okay. But raising cattle actually speeds up this water cycle. It speeds up the process of returning fresh water to the ocean. The jungle canopy provides protection to the ground from rain and slows movement back into rivers. Slows water movement back into rivers. But after the rainforest has been cleared, and as cattle walk around, they compact the earth beneath their feet, which prevents water from infiltrating and being absorbed slowly back into the water table. Overgrazing by cattle will enhance these effects by removing even more plants and making soils even more vulnerable. Many of these farms will also be along a river whose ecosystem the cattle interrupt by breaking apart and accelerating the erosion of riverbanks. All of these end up increasing the speed at which water returns to a river and then to the ocean, thus reducing the freshwater supply, not just for human use, but as well as for the surrounding ecosystem. The increase in water that returns to the river from all the, since the water is now absorbed, it runs right into the river. It results in a higher peak river flow, and which occurs after rainstorms, which means an increase in flooding and flood damage. In the Amazon, this inhibits jungle growth and over time causes other areas to lose dense greenery. And once the soil, water, and biota have been altered so dramatically, it would take immense efforts to restore the jungle, which helps provide water to everyone living downstream as well. So livestock will not only compact the soil and make it hard for water to get into it, during the dry season, they'll actually kind of kick up the soil and break it apart and just loosen it up while they graze. This loose soil is then washed into the rivers, and as the rainy season comes in, which it pollutes all those rivers that they wash into. It's something I'll talk about more later. Soil erosion is the process of rain washing away that top layer of nutrient-rich dirt. It's estimated to take 500 to 1,000 years to form that inch of topsoil. And even if these farms were to be abandoned, their intensive use and exhaustion means it will take more effort for the jungle to recover. This isn't just an issue in the rainforests of Brazil, though. This is only one example of what is occurring globally anywhere livestock are found. For example, in the US, livestock are estimated to be responsible for 55% of erosion and sediment loss. In southwestern France, irrigated maize grown for livestock feed has been found responsible for severe drops in the flow of major rivers, as well as damage to coastal aquaculture during these induced droughts. Floodplains, which are one of the most diverse types of ecosystems, are also unable to sustain themselves after livestock interference. Wetlands are important for flood control, groundwater replenishment, shoreline stabilization, storm protection, sediment and nutrient regulation, climate change mitigation, and water purification. And wetlands are estimated to provide $15 trillion of global economic benefit. Over the past 100 years, 50% of wetlands have disappeared from human expansion.
50?
50%. I also want to point out that these effects end up compounding each other. So one happens causes the next one to happen. Decreased soil infiltration of water causes decrease in average river and water table levels. Decreases in water tables level affects which plants and animals live there, shifting the environment to a drier ecosystem and increasing the chances for a drought. A drought means humans will tap the water table further to get water for their own needs, further lowering the water table and increasing the chances of a drought. This in turn affects wetlands and floodplains and causes drier and longer dry seasons, which means more soil will be loosened and washed away, and taking away all that hard-won nutrients for plants to grow in. Less plants means more runoff. Less nutrients means more fertilizer. The problem keeps feeding into itself. This is called a positive feedback loop, and when environmentalists talk about a point of no return for global warming, they're also talking about a positive feedback loop. It's called point of no return because in this example, the cycle of decreasing amounts of water becomes so strong that there would be no possibility for human intervention. But all this cattle doesn't just need the land, it also needs food. And so here we have a nice picture of soy fields. If farmers plan on raising livestock, then they're also going to grow food for their livestock. Although there's a large amount of livestock that are raised by grazing, most are not, especially in larger operations with more cattle per acre. Part of the reason for this is that livestock have degraded the land to such an extent that the land is no longer suitable to grow enough food to sustain grazing. So food has to be grown for them, which means more land has to be cleared, more water has to be used, all just to make, a burger. It's actually a lot of food. 1/3 of all crops grown are diverted from humans and instead fed to livestock. To understand why it takes so much food, we need to understand the concept of ecological efficiency. So this is, very simple food chain. You have sunlight, plants feed off the sunlight, other things will eat the plants, and then other things will eat those other things. And so food chain starts with the primary producer. Again, it is plant or algae. It'll absorb and store sunlight in the form of chemical bonds, for example, with sugar. Plants aren't that good for absorbing sunlight, though, so they end up capturing about 1% of the sunlight that reaches the Earth's surface. The next step in a food chain is the primary consumer. For example, herbivores like cows or humans who eat the plant. Primary consumers will break down and digest the plant, and in the process use the energy released for themselves. However, from all the sunlight that the plant absorbs, the primary consumer will only be able to absorb about 10% of that. That means 90% of the sunlight that the plant stores is wasted in the inefficient process of digesting that plant. Next comes secondary consumers, which are animals who eat herbivores. And in the digestive process, again, roughly 90% of the energy is lost and 10% gets to be used by the consumer.
So does everybody understand that concept?
And so the energy is way out of balance from if we would just eat directly the plants.
Mm-hmm.
We'd cut out all those in between energy losses.
I think it was so cool, like how
An accumulated effect.
we all get our energy from the sunlight. And like people are, especially when you're not eating meat, where do you get your protein? Where do you get your protein? Where do you get your nutrition from? The plants, directly.
Yeah. Yeah, so that means for 1 pound of meat to be produced, it takes about 10 pounds of feed that also has to be produced. So I also want to emphasize that this whole 10% thing, it's a rough estimate. It's meant to illustrate this idea. And this number actually varies between different species. But surprisingly, reality is remarkably close. For example, chickens have an ecological efficiency of 22%, pork is 14% efficient, and beef is 5% efficient. It takes 20 pounds of grains to make 5 pounds of beef. Wait, no, I got that wrong. 1 pound of beef. 20 pounds of grains to make 1 pound of beef.
Sheesh. 1 pound, that's 4 quarter pounders.
So with the scale that this inefficient process currently occurs, it turns out that for every 1 pound of grain that is fed to humans, 7 pounds of grain are fed to an animal. And in the US, 60% of corn and 40% of soy grown are fed to livestock, on top of all that grain. Overall, 33% of cropland is dedicated to growing feed for livestock. And because it's cheap, feed isn't just grown, it's also made by grinding up the unused parts of other animals, such as bones, organs, and connective tissue. It's actually...
What percentage, I'm sorry, of the farmland was used for?
33%, 1/3. Mm-hmm. So yeah, we end up feeding animals, leftovers of other animals, just because it's there and it's cheap. It's now actually no longer legal to feed animals food from the same species. So you can't feed cows ground up cow spines because that's how mad cow disease started. It is legal, however, to feed a cow unused chicken parts, and that includes droppings from chickens. The Physicians Committee for Responsible Medicine found that in 1994, 18% of Arkansas farmers used chicken shit as cattle feed, which amounted to 2.6 million pounds of chicken litter being fed to livestock in Arkansas. So at this point, maybe you're thinking, well, why don't we just leave the livestock to graze? We don't need to feed them. They can feed themselves. And I just want to emphasize that to do that, we need to clear more land to make more space for them to graze, because growing feed is actually more space efficient. But the other problem with, if we still went through with that, is that livestock, free-range grazing actually ends up releasing more greenhouse gases than intensive factory farming. So it's, we can make it more humane, but now we make it more greenhouse gas emissions. And livestock are already the #1 greenhouse gas emitter. Yeah, they beat out transportation, all of transportation combined. At this point, you also may be wondering how much water is being directly consumed by the livestock. In some countries, as Botswana, up to 23% of water is diverted directly to livestock. But it turns out that the global average is actually really, really low. Livestock directly use about 0.6% of fresh water supplies for drinking, for washing equipment, and for keeping the livestock cool. And growing feed for livestock takes up only 8% of global fresh water usage. But these low numbers are actually part of the problem. So the cows may drink 0.6% of water. They may be fed grain that takes 8% of the water, but they end up polluting another 62%. And that's part of the problem. When policymakers have to decide how growing feed, how to charge agriculture for water, as well as structuring the laws around how much water can be used, 0.6% is the number they use, not 70%. So imagine, you're a politician, you have to make a policy, and you say, oh, okay, they use 0.6% of water. You're going to let them go, run amok. And, yeah. And then when considering ramifications of permitting another corn, soy, or wheat farm, the government also considers that separately, not realizing or caring that a majority of that production is not going directly to feed humans. This means government policies are turning a blind eye to 91% of water used by livestock farming. A portion of this larger water usage also comes from the fact that raising livestock hurts the environment's ability to utilize rainwater, which I've already talked about. But I think you'll be surprised as much as I am by the majority of freshwater usage by humans is used by livestock contaminating and poisoning our freshwater and making it unusable. So to quote the FAO again, animal agriculture is probably the largest sectoral source of water pollution, contributing to eutrophication, dead zones in coastal areas, degradation of coral reefs, human health problems, emergence of antibiotic resistance, and many others. The major sources of pollution are from animal waste, antibiotics and hormones, chemicals from tanneries, fertilizers, and pesticides used for feed crops, and sediments from eroded pastures. The quote goes on to say that in the United States, livestock are responsible for an estimated 55% of erosion and sediment, 37% of pesticide use, 50% of antibiotic use, and a third of the loads of nitrogen and fresh water that are let into our water. Loads of nitrogen and phosphorus that are let into our fresh water. The variety of ways and the degree in which animal agriculture causes fresh water to be unusable is absolutely staggering. Contaminating fresh water means causing it to be unusable. For example, that 0.6% of water that's used to hydrate, clean, and cool livestock, well, it turns out that that water is typically released into the environment rather than processed and purified, meaning all of that manure, hair, fat, chemicals, and blood that's washed off farming equipment will end up draining to freshwater supplies, making that water unusable for anyone downstream. And the effect's the same when cattle loosen dirt in a field during the dry season, and as the rainy season comes in, the runoff picks up all that loose dirt and it carries it into the freshwater rivers, making that unusable. The same thing happens as cattle stomp over riverbanks and graze on the vegetation that holds the riverbanks together. It causes the riverbanks to destabilize and erode, which in turn causes the rivers to flow faster, increase turbulence, which then causes more sediment to be in the water and makes it less usable. The silt and sediment isn't just hard to clear out to reclaim the water, it also brings with it all the fertilizer, pesticides, manure, and antibiotics that were left in the soil. So when growing crops intensively on a farm, as long as the soil is amenable and hasn't been fully eroded, then there are two major nutrients that limit the amount of plant growth that can be eked out of the land: nitrate and phosphorus. Nitrate's necessary because it's a major component of all the proteins found in plants, and phosphorus is used by organisms to transport energy for rapid use rather than storing it like we use fat. Although nitrogen is abundant in the atmosphere, only bacteria can turn it into nitrate in the wild. Some plants, like peas, accommodate for this, and they'll do that by growing bacteria in nodules in their roots, and then other plants get their nitrate secondhand from decomposed plants. But with farming, plants aren't left to decompose, and so nitrate is taken out of the system, thus requiring it to be replenished. And that replenishment comes from fertilizer. Some techniques for mitigating this include rotating nitrogen-fixing plants with other ones like corn, and it's also possible to inoculate some plants like tomatoes so that their roots will start growing that bacteria too. However, they'll do it at a slower rate. The other major nutrient, phosphorus, can readily be absorbed by plants from the soil. However, it's not abundant enough to sustain an unlimited growing cycle that farms use. After a season of fertilization, the feed crop is harvested, it's consumed and digested by livestock, and then it returns to the ground as manure. The livestock that ate it will have absorbed some of the nitrate and phosphorus